Hello and welcome to this R tutorial. I'm super excited because today we're going to implement decision tree classification model in R. We just did it in Python for those of you who are here, and this excitement is due to the fact that we will discover a very new kind of classification. You will see that the prediction regions and prediction boundaries are something you haven't seen yet, so let's find out about that right now. So we'll quickly set our folder as working directory, part 3 classification, decision tree classification, and here is the folder. Make sure that you have the social network add CSV file. Then you click on this more button here to set the folder as working directory. Then let's quickly take our template, select everything from here to the bottom, copy, and paste it here. Alright, and now let's change a few things. So just not to forget, let's change the titles in the plot. So we will replace classifier by decision tree, and here as well. Okay, and now let's create our classifier. So in R, to create a decision tree classifier, we will use again the most popular library for that, which is the rpart library. So now just check to see if you have the rpart library in your packages. So for example, mine is right here. It might not be the case for you if you're starting R for the first time. So I'll just write this line of code for those of you who need to install it. And so as usual, it's install packages. And then in quotes, in the parentheses, you input the name of the package, which is then rpart. All right. And then to install the package, you need to select this line and execute. I won't do it right now because my package is already installed, so I'll just put that as comment. And however, we're going to include this line of code here, library, and in parentheses rpart, to automatically select this library, because once this is executed, this will be selected. As you can see right now, it's not selected, but it will be once this is executed. Okay, and now we are ready to create our classifier. So let's do this. Classifier, as usual, equals, and then we're going to use actually a function, which is the same as the library, rpart. So rpart, and in this function we will input the right parameters. So, well, as you can see right now, we can see what those parameters are, but if we want more info, we can click here and press F1, and here we just need to click here to get some info about rpart. Okay, so as we can see, the first argument is formula. So this is a parameter that we have to input. And as usual, we're going to write the formula equals dependent variable tilde dot. And the dot is a shortcut to replace the sum of the independent variables, which is the other way of writing the formula. So that's the same as usual. And then we have the data argument here, which is, of course, the data on which you want to train your classifier. So this data will be the training set. All right, so let's input the argument. So remember, the first argument was formula equals purchased, that's the dependent variable, tilde, I just pressed Alt-N, and then a dot to include all the independent variables. Then comma, and then we input the second argument, which remember it was data, and we pick our training set. Perfect, and now let's execute the whole code. So first we execute this pre-processing part here, as usual. Done, perfect. So we can have a look at the dataset all fine, with our two independent variables, age and estimated salary, and our dependent variable purchased. Training set, all good, and test set, all good. Okay, so the training set and the test set are scaled because we will plot the prediction regions with a high resolution, so we need to scale. Actually, you can try to not scale the independent variables here, because for decision tree, you don't need to scale your independent variables because the decision tree model is not based on Euclidean distance. But since we want to plot the prediction regions with a high resolution, you will see that your code will execute a huge time faster than if you don't scale it. Actually, I think that if you don't scale it, your code might break. You can try that, but be careful. So we will do it, but then we will execute the code again without the scaling to plot the tree. So we will clear everything, and in the preprocessing part, select everything except the feature scaling, and then we will plot our tree in a very simple way. But right now we want to plot the prediction regions, so we scale our independent variables. Okay, so perfect. Now the classifier is ready, so let's execute it. All right, all good. Now we can execute this line to predict the test set results. And actually what's funny is that ypred is not the same as what we were used to. First, for example, we can see ypred here. Remember before ypred wasn't in the data here, we had to type it in the console to have a look at it. And here it's here, so let's click on it to find out what it is. All right, this is ypred, and this is actually a matrix of 2 columns and 100 lines. So what is this new ypred? What is it exactly? Well, as you can see, the sum of the 2 cells here in each line is equal to 1. So can you guess what it is? Well, these are probabilities. The first column gives the probability that the observation, the user belongs to class 0, that is, doesn't buy the SUV. And this probability in the second column is the probability that the user buys the SUV, belongs to class 1, that is, buys the SUV. So here, if we look at the first observation, we can see that there is a very high probability that the user buys the SUV, 0.96, against a very low probability, well, of course, because the sum is equal to 1. And so that means here that the prediction here is that the user doesn't buy the SUV. And if we look at the test set here and look at the index 0, we can see that indeed in reality the user didn't buy the SUV and therefore the prediction is correct. But that's because we have ypred this way in our template, and if you don't want this format of ypred, well, you just need to add a simple argument, which is type here. The type equals, and you just need to input class. Okay, let's try. Let's try to execute this line again, and here is ypred. Let's have a look at ypred now. Ypred. There you go. Now ypred is a vector, as you can see. For each observation of the test set, that is for each user of the test set, we have, like before, the prediction 0 or 1 for each user. 0 if the user is predicted not to buy the SUV, and 1 if the user is predicted to buy the SUV according to our decision tree classifier. Okay, so that's a little thing to change here. Make sure that your ypred is your dependent vector of results 0, 1 that we were used to, because here, as you can see, we use the same predict function with the 2 arguments classifier and new data equals grid set. So that means that this won't work because this is supposed to be a vector of prediction results, only this time it's for all the pixel points, the imaginary pixel point users in the grid. But since the predict function is associated to the classifier, which is the decision tree classifier, then if we only keep those 2 arguments here, then this won't make any sense because this will return ygrid as a matrix of the 2 probabilities, and therefore here we will have some problem because it will be a matrix of a matrix, whereas here it's supposed to be a vector. So what we only need to do, and we will do it now so that we don't forget, is to add this type parameter, and we will set it equal to class, and then it will work perfectly. So we'll copy this and add it here as well. Perfect, and now it's ready. Now it will plot the graphs without any errors. So I know I gave you a template that is supposed to work without changing anything to plot the classifications. I'm sorry, sometimes we need to change a little few stuff, and that's why we need to, execute each of the lines one by one to see if it's as it should be. And here, since we found out that due to this little different structure of the decision tree classifier, well, we need to adjust to get the right vector of predictions ypred that we had for the previous classifiers. And so we made the adjustment for decision trees by adding this type argument here and set it equal to class. And now we have the ypred vector that we needed. And besides, yes, we would have encountered some issues if we, computed the confusion matrix this way with this ypred as a matrix of probabilities. But now it will be fine because ypred is set the correct way. So we'll execute this and look at the number of incorrect predictions. All right, now let's enter CM here. And we have 6 plus 11 equals 17 incorrect predictions. So now let's see if we we're right to change our code this way so that we can plot the graph. Let's see if it will work. I hope it will work because I want to show you the decision tree, prediction regions, and prediction boundary. I really want to show you this for those of you who didn't follow the Python tutorial, of course. So let's select this and let's see if we made a good job. All right, looks good. So far it looks good, no errors. Let's see what happens. And we were right. This works perfectly well. That's the decision tree classifier. That's the prediction boundary. So as you can see, there's only horizontal and vertical lines. That's because, as Kirill explained, the decision tree algorithm is based on some conditions of your independent variables by finding, each time intervals that will make conditions that will classify in some rectangles your observations. And actually what's funny is that we clearly have less overfitting than in Python, and actually that's why we have more incorrect predictions, because in Python we had, red rectangles here, red rectangles here. There was also red rectangle here. And here we didn't actually specify more parameters, but this amazing rpod library, and that's why it's very popular, chose the right parameters, the right default parameters to, prevent overfitting, because here we clearly don't have overfitting. We had overfitting with Python because of all the red rectangles here that were desperately trying to catch every user in the right category. But here it's not the case, and here it's doing a terrific job at, classifying correctly most of the red points here, most of the green points here in the right region, and as well as these green users here who couldn't be well classified for linear classifiers such as logistic regression or linear kernel SVM. So here it's doing a pretty good job, but still we have some incorrect predictions. That's because that's difficult to classify well if you want to prevent overfitting in your data. So even if we have 17 incorrect predictions, that's a very good classification we have here. Okay, but now let's look at the test set results, and I'm actually not too worried about that because since we don't have overfitting here, then that means that we're very likely to have some good results as well on the test set. Let's check it out. Test set and execute. Let's see. And here is the test set. Okay, so as I told you, this looks very good. This is the set on which we have those 17 incorrect predictions. You can count them if you want, you will find 17. And it's classifying most of the red users in the red region and most of the green users in the green region, so that's quite okay. By the way, we can see that most of the incorrect predictions are here. We can see that we have many red points in the green region, so that's unlucky. But as I told you, we would rather prevent overfitting than trying to minimize to zero the number of incorrect predictions. So there it is, another new kind of classifier, and therefore another new kind of prediction region and prediction boundary. And now in the next section you will find out about random forests, who are actually a team of decision trees, of many decision trees. A random forest can contain 500 trees. And so each decision tree of the team will vote for each data point whether this data point belongs to class 0 or class 1. That is, it will vote for each user if this user bought the SUV or didn't buy the SUV. And based on a majority vote, it will decide if each point belongs to the red region or the green region. And so I'm telling you this because, since here we have the job of one decision tree, imagine the job of an army of decision trees, like 500 decision trees. Imagine what it could do to classify the results. But let's not get too enthusiastic about that. Remember that we want to prevent overfitting, so let's find out anyway. Alright, and now time for the little extra bonus. Let's plot the decision tree. So in order to have the best interpretation, we're going to remove the feature scaling, and to do this we're going to clear everything and re-execute the code, but without feature scaling. So let's do this. We're going to clear the data here by clicking on this button here, and yes. Then clear the plots here, yes. And then clear the console as well by typing Ctrl L. Here we go. Alright, now everything is clear. We can re-execute the whole script. So let's do it step by step. We're first going to take all the pre-processing step, but without the feature scaling here. As you can see, I'm not selecting this. Alright, so now Command and Control plus Enter to execute. All good. And now you can see that if we go to our data set, training set, and test set, you can see that the features are no longer scaled. Alright, so for example, in the training set, we have the real age, with their real values, and the real estimated salaries, the real values. Okay, so nothing scaled now. Let's select this to fit the decision tree classifier to the training set. So Command and Control plus Enter to execute. Here we go, now it's fitted. By the way, I'm just going to replace this by decision tree classification. All right. What we are really interested in right now is to plot the decision tree. So we're going to add a new section here below, and I'm going to call this section plotting the decision tree. And as I told you in the Python tutorial, this is going to take 2 lines. This is very simple, so let's just do it. It's going to be very quick. Okay, and besides, the 2 lines that we need to write could not be more simple, because indeed what we need to type here is plot, and then in parentheses, classifier. Because the classifier here is the classifier that we created here in this part using the rpart function of the rpart library, and that's all. We just need to type plot classifier, and that will plot the tree, but without the labels, without the conditions written explicitly. So in order to add these conditions written explicitly, we just need to add below text classifier. Here we go, and now it's ready. Isn't that simple? These only 2 lines will plot an interpretable decision tree. Let's check it out. I'm going to select all this and press Command and Control plus Enter to execute. And here is the tree. So as you can see, we have at each split the condition that is generating the split. So for example, the first split is made based upon the condition age lower than 44.5 years old. So that means that if the user is below 44.5 years old, he will go to this subcategory after the split. And if the user is older than 44.5 years old, he will end up in this subcategory of the split. And then we have some new conditions. So here, a new condition on the other independent variable, the estimated salary, and this condition is estimated salary below $90,000. So what that means is that if the user is younger than 44.5 years old and has an estimated salary below $90,000, then according to our decision tree classifier, this user won't buy the SUV because the result here is 0. And if the user is younger than 44.5 years old and has an estimated salary over $90,000, then according to our decision tree classifier, this user will buy the SUV because the result here is 1. Okay, and if we go to the other side of the tree, well, this other side of the tree first contains all the users that are older than 44.5 years old. And then we have some new conditions generating new splits. So another condition on the age here, then another condition on the estimated salary, and then again another condition on the estimated salary. And following yes or no these conditions, we end up in some final categories, the final nodes of the decision tree, where the user is predicted not to buy the SUV for this node and predicted to buy the SUV for this node and this node and this node. Okay, so that was worth looking at this. We sort of explored this decision tree classifier behind the scenes. And what's important to understand now when you are using decision trees is that a big advantage of this classifier is that we can have these very interpretable results, because here on this decision tree plot, we can see everything that's happening. We can see how the decision tree decides whether a user will be predicted to not buy the SUV or to buy the SUV. We clearly see the whole thinking process of the decision tree, and in some way we saw how it learned from the data how to classify each of our users of the social network. Alright, so I look forward to seeing you in the next section about random forest. We will implement random forest on Python and R, and I can't wait to show you the final graphic results. Until next time, enjoy machine learning!